Question 76 to 77 is based on the information above. A wave travels through a uniform medium and has an amplitude of 0.2 meters, a wavelength of 0.4 meters, and a frequency of 10 hertz. In question 76 to 77, we have to draw one complete cycle of this wave. So as I'm drawing the wave, I need to make sure my amplitude is 0.2 meters high and my wavelength, or the length of one wave, is 0.4 meters. So we're going to start here at 0 and we're going to end at 0.4. Well, halfway in between those two, I'm also going to be at the equilibrium position, so I'm going to put a dot there as well. Heading toward that spot, my amplitude is going to be 0.2, and my amplitude is negative 0.2. And if you connect those lines there, you'll end up with a beautiful looking wave. Oh yeah, look at how nice this looks. Yep, there you go. That fits the amplitude of 0.2, and it fits a wavelength, or the length of one full wave, in 0.4. Question 78 to 79. Calculate the speed of the wave. Well, in order to calculate the speed of a wave, I got to go to my reference table and look at that formula. I'm under the section for waves, and the speed of a wave, represented by v, is frequency times wavelength. My wavelength is 0.4 meters. My frequency is 10 hertz, and I have to calculate my speed. So I got my list of givens. V is frequency times wavelength. That frequency is 10 hertz, once again, and my wavelength is 0.4 meters. Don't forget to write your units. So that would give you a velocity of 4 meters per second. Finally, question 80, determine the period of the wave. Well, in order to figure out the period of a wave, period we use t to represent, and t is just simply 1 over the frequency. So I use this formula. Period is 1 over my frequency of 10 hertz. So that's going to be 0.1 seconds. 0.1. All right, last few problems. In an experiment, the potential difference, or voltage, applied across an unmarked resistor was varied while the resistor was held at a constant temperature. The corresponding current through the resistor was measured. The data collected in the data table here shown below. Hey, this is similar to what we did in lab. Remember we used Excel because it, well, excels over Google, which the school teaches you. At any rate, since we're using real-world software, Excel, this shouldn't be too bad. Oh, we're on a test, so I guess we can't use Excel. So what do we have to do? We have to mark an appropriate scale that's labeled current on the x-axis. And notice these amps here. These amps are 0.0032, 005, 01, 017, 02. So in my head, I'm thinking, well, we have to count by 0.001s if possible. And if we look here, we got 0.001, 002, 001, 002, 003, 004, 0.005. And then this would be 0.010. This would be 0.015. This would be 0.02. And then finally, we'll end up with 0.025 here. So again, we're counting each one of these things is counting by 0.001. Okay, so that's 002, 003, 004. I'm going to erase those, but I just did that lightly. I would suggest you do that lightly with a pencil to figure out how to count on your test. So in this case, potential difference is 1.5 volts. My current is 0.003. So 0.01, 02, 03, and I'm at 1.5. Okay, so this is 1, 2, 3, 4, 5, 1.5, so that's here, 0.01, 01, 03, a little bit more. So this is going to be about where my dot is going to be, right in this general location. Next one, at 3 volts, I got to go to 0.005, and just a teeny tad more. So I'm just going to kind of, and if you make a big enough dot, that covers that. And now you don't be too crazy with the dot though. 6, and now we're at 0.124. So 6, we're at now 0.0124. So 0.01, 0.011, 0.012. So it's going to be right here in this general area. And now at 9, we're at 0.017. So this is 5, this would be 6, this would be 7, and I'm at 9. I'm at 9. So that's going to be right here. And next up, 0.024, 0.02, 0.021, 22, 23, 24. So it's going to be right here, the second to last line, and I'm going to go up to 12. So about right in that area. There we go. Now it says plot data points. I did that. Draw a line, curve, or best fit. This obviously looks like a fairly linear line. So we're going to do just a line here through this. Best fit line, the best we can through our points. Bam, there you go. Easy, like that. And then finally, what else do we got? Using your graph, calculate the resistance of the resistor. Show all work using the equation and units as always. So we're using the graph to figure out the resistance of this particular object. Notice on the graph here that we have voltage on the y-axis, current on the x-axis. So the slope of that line...
What is your slope? Please don't be shy. What is on the x? What is on the y?
Is y over x. So we've done this multiple times. So this is V over I, which is equal to resistance. So to calculate the resistance, you just got to calculate the slope of the line. Pick 2 points that are on that line. I'm going to pick 1 point here at the bottom, and I'm going to pick 1 point here at the top. This is going to be y2 minus y1 over x2 minus x1. So I'm going to have 12 volts. Notice how I'm putting my units in. Otherwise, you'll lose points. Minus 1.5 volts, all divided by 0.024 amps minus 0.0032 amps. This gives you a resistance of 495 ohms. I hope this helped you study for that big game day, and I look forward to seeing everyone there. As always, if you have any questions, don't hesitate to reach out. Congratulations, you finished all of 2019 Physics Regents exam. Use the links to revisit any pages that you desire. And best of luck on this year's exam. Remember to say, let's get it.